Welcome everyone, back to examination solutions. We're looking at discrete random variables today and going to go through lots of examples. Question 1. In a small town, 40% of the population attend the Saturday afternoon first grade rugby league match. If 600 people are selected at random, calculate the standard deviation of the distribution correct to 2 decimal places. N, the size of our sample is 600. P here is that 40% of the people attend the game. The standard deviation is the square root of variance, where variance is NP times 1 take P. Well, 1 take P can also be called Q. That's the chance of failure. Subbing those values in, 600 for N, 0.4 for P, and 1 take 0.4, which is 0.6, and that is 12.00, the standard deviation to 2 decimal places. Identify which of the following are discrete variables. Note, there is more than one correct answer here. The height of a person can be any value. The outcome of rolling a die is fixed to 6 values, so B is discrete. The result of flipping a coin, you're either getting a head or a tail. The number of cars in a car park is also fixed to certain values, distinct outcomes. The weight of a newborn baby is continuous. The time between buses arriving at a bus stop is continuous. The depth of snow at a ski resort is continuous. So B, C, and D have distinct or countable outcomes and are discrete variables. Question 3. Suppose that a netball player has a probability of 4/5 accurately completing a shot each time she attempts to shoot. She repeatedly attempts shots. Identify if this scenario is a Bernoulli sequence by recognizing and describing distinguishing features. Yes, it is a Bernoulli sequence because of the following reasons. Each trial results in one or two outcomes, success or failure. The probability for success on a single trial is constant for all trials, and the trials are independent of one another. Question 4. X, which is a random variable, follows a binomial distribution with n equaling 10, the sample size, and the probability of success being 0.75. Calculated distribution's mean. This is saying that our random variable is binomial distribution where n is 10 and the chance of success is 0.75. So our mean is n times p, 10 times 0.75. We're expecting to get 7.5 shots or 7.5 successes. The variance is sigma squared, and from your real page, that's n times p times 1 take p, which is your failure. So that's 10 times 0.7 and 1 take 0.75, and 1 take 0.75 is 0.25. Evaluating that, our variance is 1.875. And lastly, to work out standard deviation, let's take the square root of variance, which is 1.369. Question 5. A fuel additive has been created that improves engine performance 75% of the time. Given the effectiveness is defined as the discrete random variable, determine the following. Better construct a probability distribution table for X. In that case, X is a Bernoulli random variable. In this case, you really success or fail, or 0 successes or 1 success. So here's my fail, here's my success. There's a 25% chance it fails, and there's a 75% chance it succeeds, which is my distribution table for X. The expected value is n times p. So that is 1 times our 0.75, which is 0.75. And here, you could actually work it out using the same methods using a table. 0 times 0.25 plus 1 times 0.75, which is still going to get you 0.75. The variance is NP times Q. N is 1, P is 0.75, and 1 take P is 0.25. So the variance is 0.1875. A statistician is investigating how often teenagers play a sport. She locates herself at the entrance to a school indoor sports center at lunch and has the students complete a questionnaire. Do you think this sample will be representative of a general school population? Explain. No. The students who go to the sports center at lunch are likely to view sporting activities differently than a student who sits at lunch, at a lunch bench top or a library, for instance, or any other sort of valid supporting argument. Describe the alternative procedure that would ensure randomness. The method should result in a sample that is representative of the whole population. Consideration should be given to ensuring subgroups are equally represented in the sample. Question 7. A test contains 8 multiple choice questions, each with 5 alternatives for the answer. Let X be the discrete random variable that describes the number of correct answers. So you've got 5 alternatives, so you could have a multi-choice test that's got A, B, C, D, E, so you get a 1 in 5 chance of guessing it right. Assume all responses are guessed by the respondent. Determine the expected number of questions answered correctly. The expected result of new correct answers is given by n times p. We're having 8 questions. We have a 1 in 5 chance of getting those questions right. We're expecting to get 1.6 questions correct if we guess. Calculate the probability of correctly answering exactly 5 questions. We're going to use or apply the binomial formula. It's the probability of r successes out of n attempts is p to the r times 1 take p to the n take r. The first one is a combination. So 8C5 is a calculator. Our P is a 20% chance, and we want 5 questions correct. 1 take 0.2 is 0.8. That's our chance of not getting it right, and we've got to get 3 of those questions wrong. Note that 8.5 is 8C5. Evaluating that on a calculator, we really only have a 0.00092 chance of actually getting 5 questions right. It's exactly 5 questions. The next one is getting at least 4 or more questions right. So using a Casio, our lower boundary is 4, our upper is 8, our number of trials is 8, and we have 0.2 as being P. So we go through the stats mode. We're going to choose distribution and binomial. Then going to choose cumulative because we're saying 4 or more. And I want 4 to be my lower, 8 to be my upper. I'm taking 8 questions, I have a 20% chance of getting it right. And for me to really pass this test, I've got about a 5.6% chance of passing if I guess. Question 8. A discrete random variable x has the following probability distribution. Calculate the expected value of x, correct at 2 decimal places. Now, being a table, we simply multiply 0 by 0.12, then we add 1 times 0.36, and so on. So expected value is 3 times 0.14, 2 times 0.38, 1 times 0.36, and 0 times 0.12, and add all those up, and our expected value is 1.54. The thing about it, you've got options of 0, 1, 2, and 3, and these 1 and 2 seem very likely, and 1.5 is in between those two roughly, which is what your expected value is. Calculate the probability of getting 3 right, given x is greater than 1. So x being greater than 1 means you are 2 or 3. So the probability of 3 divided by the probability of x being greater than 1. So the probability of 3 is 0.14. And the probability of being greater than 1 is your 0.38 plus your 0.14. That's a conditional probability, which is 0.27. A new drug that cures travel sickness is successful in 95% of cases. Use the binomial formula to determine the probability that in a group of 20 people, all except 1 are cured. This is a binomial experiment where n is 20 and p is 0.95. Applying the formula, we can work out 20C19. Our successes to the power of 19, our failures to the power of 1, and that is 37.74% chance. Validate A using technology. So we've gone back to our stat menu, distribution, we're going to choose binomial PD because it's 1 we're choosing, like exactly 19. So we want 19 out of 20, where P is 0.95. So 19, 20.95, we press enter, and we get the same answer, 0.37735. Lottery claims that 10% of tickets win a prize. Determine how many tickets should be purchased to be 50% sure of winning at least one prize. So a bit of a thinking question. Let x be the number of successes. This is a binomial experiment. with P being 0.1 and N is unknown. Now, winning at least one prize means the number of successes is greater than 0, that you're 1 or more. With this in mind, we want everything but 0 scores. So let's work out 0 successes and take it away from 1, because for us to get 0, we must have got 1 or more. So the probability that your x is greater than 0 is equal to 1 take the probability of x exactly being 0. This helps us out now because I want the 0.5, 50% chance. There's my 1. Now for exactly 0, it's NC0 because I don't know n. There's my success, there's my failure. I want 0 successes, I just don't know how many failures. Now I'm just going to evaluate. Now anything NC0 is 1. 0.1 to the 0 is 1. And now I've got an equation with the power, so we might have to use logs. Simplifying this, I have 0.5 equals 1 take 0.9 to the power of n. If we rearrange and take 0.5 from both sides and then add 0.9 to the end of both sides, we get 0.5 equals 0.9 to the power of n. Now we could solve this using logs. We could write log base 0.5 n equals n, or we take the log of both sides, log base 10, and it's log of 0.5 divided by log of 0.9, n equals 6.57. So I should buy 7 tickets for a slightly greater than 50% chance of winning, or buy 6 tickets for a slightly less than 50% chance of winning. There are 5 traffic lights on the highway between Amityville and Bobtown. The City Council has determined the number of traffic lights at which a driver will have to stop along the highway has the following distribution. So we've got 1, 2, 3, 4, 5 traffic lights. Here's my probability, but we've got k's here. We've got to calculate the value of k. 1, 2, 3, 4, 5. These probabilities have to add up to 1. So we're going to sum these and calculate or solve for k. Adding the right hand side up, we get 5k. Now if we divide both sides by 5, k is 0.2. So you could now rewrite each of these if you wanted to. So that's 0.2, that'll be 0.4, that'll be 0.2, that'll be 0.1, and that'll be 0.1. Probability of being greater than 2 is your 3, 4, and 5. Adding those up, your 0.2 plus your 0.1 plus your 0.1 is 0.4. Suppose a random variable x has a probability distribution given by the table below. We have 2 unknowns, which is a and b. But we've got to work these out. We know the mean of x is 0.7. So we've got to try and create 2 rules or formulas or equations to simultaneously solve. So these 1, 2, 3 values have to equal 1, because that's what the sum of probabilities has to be. So 0.5 plus a plus b has to equal 1. I could simplify this by taking 0.5 from both sides. That's equation 1. Now the expected value we know is 0.7, and that is 0 times this, plus this times this, plus this times this. So let's write that formula. 0 times 0.5 is nothing, 1 times an a is an a, and 2 times a b is 2b. So we've got formula 2, or equation 2. 0.7 equals a plus 2b. We can simultaneously solve now. You could have equation 2 take equation 1. So 0.7 take 0.5 is 0.2. 2b take a b is 1b. So b is 0.2. If you know b is 0.2, the other one's got to be, a is got to be 0.3, because these two have to add up to 0.5. So we simultaneously solved and determined a and b. That's the end of our discrete random variables 2 practice exam. Keep studying and good luck on your exams.